Welcome back to Geometry. In our third and final installment of Q2, our special parallelograms, we have squares to add to the mix. Now a square, as we're all familiar, is all equal sides and all equal angles. So all equal sides, just like a rhombus, all equal all equal angles, just like a rectangle. So a square has all the properties of rectangles and rhombuses, and since those are also parallelograms, we're going to include that here. So parallelograms, square has all the properties of a parallelogram, rectangle, and rhombus. So all those properties that we just talked about in the last two videos, it inherits them all. Okay, equal sides, perpendicular diagonals, equal diagonals, bisected angles. But squares, in addition to that, all the angles are congruent and right. Just like with rectangles. And the diagonals are congruent and bisected. And perpendicular. And as we've seen in our last unit, when we talked about the diagonal being drawn in a square, since in a square the rectangles or the angles are right angles, and the diagonals bisect those right angles, it creates half of 90, 45. So every triangle that you see, every triangle in this picture is a 45, 45, 90 right triangle. So not only are the corners right angles, but the diagonals are perpendicular as well. And so these little triangles are 45, 45, 90, and the big triangles are 45, 45, 90 right triangles. Pretty cool. So we can use those relationships, those special right relationships. In a square, the diagonals bisect the opposite angles, and they also bisect each other. So this makes all of the bisected angles 45 degrees. So in this picture here, we have AB is 12, and just to make sure that this does not work. So AC is not 18, AC is 12 root 2. Okay, so AB is 12, AC then would be 12 root 2, but if AB is 12, then those sides are going to be 12 as well. And BC, is 12. CD, also 12. DA, also 12. AC is 12 root 2, so BD also be 12 root 2. And AE is half of that, 6 root 2. BE, also 6 root 2. CE, also 6 root 2. And DE, also 6 root 2. So then our angles, notice they don't give us any of the angles. We're just going to be looking at, based on which angle we're talking about, they're either 45 or they're 90, right? Those are our only options. So A, B, E, that's a 45 degree angle. C, D, E, also 45. A, E, B, that's a right angle in the middle there, that's a 90. EBC, also 45. EDA, 45. BEC, 90. BCE, 45. DAE, also 45. CED, ED 90. ECD, ECD 45. EAB, EAB also 45. And DEA, DEA 90. Okay, so all those ones in the corners, those are all 45-degree angles. If we had to say angle DAB, right, that's 90, or ABC, that's 90, but the halves are all 45. Okay, pretty cool. Nice and easy for squares. So then when we have equations, or when we have examples to set up, if we know that something's a square, well, then we can use any of those properties. So we know that the sides are equal in a square, so we can just say 16x minus 7 equals 20x minus 91. And subtract to get 4x minus 91 equals negative 7. Add the 91 to get 4x equals 80. What is that, 4? 84. Divide by 4 to find x is 21. And this one, we're only given one expression, but since we know it's a square, 7x plus 13 is 90. 7x plus 13 equals 90. And we can solve. There we go. So we'll subtract 13. So 7x equals 77, and then divide by 7 to find that x is 11. Here we have some diagonals drawn in here. This angle, we know that all the angles. Oops, we know all the angles other than the corners are right angles, and these are half of those right angles. These are all 45. So 9x minus 9 equals 45, even without any other information. If we know this is a square, then we know that that angle is a 45-degree angle. So we can add 9 to get 54, and then divide by 9 to get x is 6. Okay, we'll do those last three in class, along with our rhombus and rectangle examples, and I will talk to you then. Bye for now.